Hey everyone, so today we'll be talking about some things called functions. Do you guys know what a function is? Think about your past experiences, especially outside of programming, and the way the word is used in other places. What do you think? Pause the video here and think about it, and then when you unpause, we'll talk about it more. Well, when we talk about something having a function, we typically mean that it does something. It accomplishes a certain task that we need to get done. For example, the function of a fan is that it blows air to cool you or your area down. So, using that logic, what do you think the function of a bookshelf is? Well, it would be to hold books. In programming, functions are just a little bit different. They are still things that do something for you, but a better way to think about them is as repeatable sets of instructions. At a very basic level, computers are just really powerful calculators, and the only way to get them to do useful and helpful things for us is by giving them instructions. That's ultimately what computer programming is, giving computers a set of instructions to perform a certain task that does something for you. But as you'll see, as you continue learning programming, you'll need to find the most efficient way of giving the computer instructions because it'll A, save you time, and B, make it easier for both you and the computer to understand. For example, think about writing a program that tells a robot how to tie their shoes. What kinds of steps would you give the robot to tie both of its shoes? You could tell it to put the shoe on, cross the two laces to make an X, take one of the laces under the hole under the X, and pull, make a loop for both of the laces, take one of the loops and pull it under the other, and then tell it to follow the same steps but for the other shoe on the other foot. It would look something like this. You would put the right shoe on or the left shoe on, cross the laces and make an X, take a lace and pull it through the hole under the X, make a loop for both of the laces, take one loop and pull it under the other, and then put the other shoe on, and yada yada yada, the same steps. So that is a lot of instructions. So do you notice how the only difference between the first half and the second half is which shoe you're tying? Otherwise, the instructions are exactly the same. This isn't the best way to do things. The biggest reason we use functions in programming is to avoid repeating the same steps of instructions over and over. That's why, when we have a set of instructions that do something specific, we give it a specific name and call it a function. Then, when we want to do that specific thing, we don't have to keep writing the same instructions. We can just call or execute the function. Now, in the shoe tying example, we can actually take the first 5 instructions, the original ones that actually matter, and make a function. We can call it tie your shoe, the right one or the left one. So, the 5 instructions would be, first, put the shoe on. Second, cross the laces and make an X. Third, take one of the laces and pull it through the hole under the X. Fourth, make a loop for both of the laces. And then fifth, take one loop and pull it under the other one. So do you notice how we wrote right/left next to the name of the function? Those are just the 2 different shoes we will be tying. And even though the instructions are the same, we'll be doing them on 2 separate shoes. So then, now it's completely simplified. All we need to tell the robot is, first, tie your shoe, the right one, and then tie your shoe, the left one. Makes it very simple. So now let's talk about functions in Snap specifically, because that's the language we'll be working with throughout this entire course. As we talked about earlier, a function is just a set of statements that do a specific job or some sort of calculation. In Snap, there are tons of functions that do all sorts of different things. There are some for moving your sprite or a character to a certain place on the screen, draw something, getting some information from the user, and finding out if 2 words are the same or not, and many more. So now on the screen, you can see a bunch of examples of how to do the things we talked about just now. I'll let you take a look at it on the screen, but if you want, you can go back and take a look at it again. Okay, so in Snap, there are exactly 3 types of functions: commands, reporters, and predicates. They are all functions, but they each work a little bit differently. The main difference between them is whether or not they return something or send you back a value. So the command functions just do something, and they don't give you any information back. Reporters want you to give them some information, and then with that information, they calculate something and give it back to you. Predicates will take in some information and tell you if something is true or false, right or wrong, 1 or 0. So if we look at the examples we have here, for commands, the example is the move block, which just lets you move your sprite on the screen some number of steps that you specify. All you have to do is specify the number of steps. And it's not doing any calculations with that, it's just making some sort of move, some sort of action. Now for the reporters, we have a multiplication reporter. So you can provide two numbers that you want to multiply, and the response will be 6. In this case, because we're multiplying 2 and 3. Now for predicates, we have the equals block, which lets you compare two different numbers or two different strings to see if they're the same or not. So if we see 3 equals 7, is that true or false? Obviously that's false, so we know it's false. But you might think, well, what's the point of this? It just seems so simple. Why do we even need a block for that? Well, later on, when we're working with variables that we don't know their value, we can just plug them in and it does the work for us, checking if some variable is equal to another variable. And that'll be very useful later on. Now, let's test some of them out and let's talk more about them. But before we do anything, you need to learn about a super important block in Snap, the when clicked block. This block is what makes your code run when you want it. Whenever you want to run your code, you will click the green flag at the top right of the screen, or the when clicked block, which will be at the very beginning of each program or script that you write. So now on the right of the screen, you see this script, which seems very interesting, and I want you to try it out later on your own, once we finish the presentation. Now, finally, let's get to talking about the categories, all the different categories that are in Snap, and all of the different functions that are really important for this course. So Snap organizes all of the blocks or functions into 8 different categories: motion, looks, sound, pen, control, sensing, operators, and variables. First, the motion category has blocks related to the motion or movement of a sprite, which is really interesting because there are a lot of cool ways we can move our sprite. First off in this category is the move block, which, as per its name, moves your sprite straight on the screen. So if it's facing right, it'll move however much you want in that direction. If you're facing down, it'll move that much down. Basically, like any block, it has two basic parts to it, the name and the input. The name obviously tells you what the block does, so even if we don't go through it here, you should be able to figure it out. Then, the input is just the information that you'll need to give the function for it to do its job in the way that you want. For example, with the move block, you control how much the sprite moves in the direction that it's facing. If you tell it to move 50 steps, it'll move that much. If you give it 200, it'll move 200 steps. It's all in your control, so experiment as much as you want with it. Now this short script just moves the sprite from the left side of the screen to the right side. It's pretty simple. Take a look at the instructions and see if you can understand what's going on. And this one is a little bit more interesting. It makes the sprite go in a circle on the screen. Then we have the turn block, which, you guessed it, turns your sprite by some angle that you provide. There are 2 turn blocks though, one for turning right and one for turning left, a certain angle. Before we do anything, any turning specifically, how many degrees do you think the sprite can turn to get all the way back to its original position? The answer would be 360 degrees. So then, a quarter of a circle is just 90 degrees, and moving a half circle would be 180 degrees. Then there's the point in direction block, which lets you put in a number for an angle, and the sprite will turn to that angle. Now, directions in Snap are based on this figure on the right. There are 4 different main directions. There's up, which is 0 degrees, right, which is 90 degrees, down, which is 180, and left, which is 270. So these are the 4 main angles that you can turn to. However, if you want to turn to some other random angle, like, say, northwest, you would look at the halfway point between north and west, so up and left. So that would be 315 degrees. This block lets you turn the sprite in random directions, so this is the script that's doing that. Then there's the point towards block, which will point towards either a random position, the center of the screen, or your mouse pointer. We can actually write a script with this block to make our sprite follow our mouse pointer around like a little puppy. The script looks like this, and there's the sprite following the mouse pointer. Then we have the go-to block, which moves your sprite to a specific position on the screen. The center of the screen is 0, 0, and the screen is 480 steps wide and 360 steps tall. This means from the center of the screen, you can go 240 steps to the left and the right, and 180 up and down. Here's a script that lets you draw things, like on a canvas or a whiteboard, and we'll definitely dissect this more and talk about it more later on our own. However, now, just take a look at this script, and it might seem a little bit intimidating, but just remember, we'll be coming back to it, and you'll learn how to make something as cool as this. Now let's look at the looks category. Really, though there's a ton of blocks in this category, the only one that we'll be using is the say block. This block lets you make your sprite say something like this. You can say, "Hey there," or say, "Codevate is awesome," for 2 seconds. There are 2 blocks, as you can see. There's a say block, which goes away as soon as the next block is called, and the say for block, which waits the amount of time that you want before executing the next instruction in the program. So here's a demonstration of the say block and how it works. First it says, "Check it out, this script is using the say block to make me speak." Pretty cool, right? Next, we have the pen category, which lets you control how you draw things on the screen. There are 2 key blocks that you need to know, pen up and pen down. These will let you stop or start drawing as your sprite moves across the screen. We can write a script that makes a line if we put our pen down and move our sprite forward. Later, if we want to pick our pen up and stop drawing for some time, we can call the pen up function. There are also other pen functions that you will use less often, but are still useful to know. The set pen color function lets you change the color of your pen when drawing. The default for this is black, and there are a ton of options to choose from. The pen down block returns true or false depending on whether the pen is down or not. You might think this is easy to tell, like it's pretty obvious if the pen is down or up, and that it won't be useful. But actually, this pen becomes very important when you're working with a large script in which it's difficult to tell how something is working behind the scenes. As you can see, you can make something as simple as a square to more crazy and awesome shapes like a spiral. We'll be doing this later, so get excited. The sensing category is all about being able to tell what's happening in the program. There are a lot of blocks in here, but we will probably only be using one of them. So this is the ask function and the answer block. This allows you to get user input or information from the user, like words, sentences, or numbers. Basically any of the data types we talked about in the first class. You can get that from the user and then use it later in the program. So this data from the user is stored in a variable, an automatic variable, a built-in variable in Snap called answer. Now we'll need to use this answer block to access all of that data. We'll talk about this a little bit more in detail later. Now for operators. All of the functions in this category help you work with numbers and strings and do calculations. As you learned last week, we can use the 4 basic operations: addition, subtraction, multiplication, and division, as well as powers and modulus. There are a few more functions though. The join function lets you join as many strings as you want together. For example, running this join co, di, and ve, and t puts all of these small strings together to form Codevate. Here's an example of the join function in action. you can see that you're giving Snap 3 words to join together, and your sprite tells you what the newly joined string is. In this case, we give 3 separate words: what, is, and snap, and the 3 words are then connected by spaces. So now let's take a look at this big program, which actually is what enabled the sprite to do all those things in the previous slide. First, at the beginning, we say when clicked. What is when clicked? When clicked is the beginning of the program. It just starts everything. Next, we say clear. We clear the screen. Then we say nothing to make the sprite clear all of what it's saying or what it said. Next, you might see this block and think, what is that? Script variables? That seems very complicated, but really it's not. If we look at the next few blocks in this sequence, we are asking the user for some information, specifically some words, and then getting the answers. But the issue with the ask and answer block is that once we get an answer from the user from one block, it's reset. So if we ask the user what is the first word and then wait, and then get the answer, that answer or that word is stored in the answer block. But when we ask the user again and the user puts in another word, the answer block has a different value. So what we need to do is store the values that we get from the answer block in separate variables, like answer 1, answer 2, and answer 3, which are just the words from the first ask and the third ask. Then at the end, we just tell the user your new joined phrase is answer 1, answer 2, answer 3, and it just puts all those two together. Now the last category is the variables category, but we'll be learning more about this in a few classes. Now, it's finally time to put your knowledge to the test and do some really interesting exercises. Head over to the link on the bottom of the screen and let's start doing these exercises. Now, the first one says, ask the user for a length in inches and tell them that same length in centimeters. And then the hint is, there are 2.54 centimeters in an inch. So all you need to do is take the information, the number that's given by the user in inches, and convert it to centimeters. So if we look at the example on the right side, the sprite asks, how many inches do you want to convert? And then says, okay, however many inches you gave is this many centimeters. So 1 inch is 2.54 centimeters. So pause the video here and do the example, and then we can talk about it in the next slide. So hopefully you've paused the video now, unpaused the video, and done the example, and you can see how well you did. So first we have the when click block to start our program. Then we ask, how many inches do you want to convert? And then we wait. And then we have a variable called inches where we store the answer that they gave. So if we said 1 inch, that would be inside answer when we say it, and then it would be put inside the inches variable. Then we're going to have another variable called centimeters and store it, and inside it we're going to store whatever inches is times 2.54. And then we're going to say inches is centimeters. So whatever is inside the inches variable, that many inches, is whatever is inside the centimeters variable, that many centimeters. Now for the next example, it says, create a script that makes your sprite draw a square on the stage. So the hint is then, think about how the angles work in a square. So for this one, you may have gotten 2 solutions, depending on what you know about loops in Snap, which is actually what we'll be talking about 2 classes from now. First, you would say when clicked, so start the program, then say nothing to clear the output on the screen, and then clear the screen, and then pick the pen up, and then go to x0, y0, and then point in the direction 90, and then put your pen down, and then move 100 steps forward, wait half a second, turn 90 degrees, wait, turn 90 degrees, wait, turn, and just keep repeating those instructions over and over. So really, you're doing the same 2 instructions over and over. You're moving, then turning, and then doing that again, moving and turning, and then you move and turn again. and you move and turn again, you're just doing that 4 times. So the reason that there's 2 solutions here is that really they're the same thing, except the right one just looks a lot simpler because we use a loop. And we'll actually be talking about that in a future class. Next, we're going to ask the user for a string and then split that string at every space that's in it. So think about what kind of function you could use to split a string. Pause the video here, do the example. Now, this one's pretty simple. All we're going to do is clear the screen, ask the user for what the sentence is that they want to split, and then say, thanks, your split string is something. So what is that something? We're just going to use the split function, put in the answer, or the string for the answer that they gave us, which is the sentence, and then split it at every space. So what happens then, if we go back, is that this string is put into something called a list, which is just a list of stuff. So the list will then have a bunch of words in them that make up the string. So we have the quick brown fox jumped over the lazy dog, which is just all of the words in the list, in the sentence. Thank you so much for watching this video, and I hope you understood everything and are excited to continue learning in Snap. If you have any questions or concerns whatsoever, feel free to email us at team@codivate.org or DM either Ritvik or Aditya on Discord.